Hi, fourth graders, and welcome to day 2 of adding tenths and hundredth fractions. We're also going to talk about subtracting during today's lesson. We're going to jump around a little bit. So today we're actually doing 4 pages together. We're doing 523 and 524, which is adding, and then 529 and 530, which will be subtracting. And then when you're done, you're just going to work on your blue iReady lesson for adding tenth and hundredth fractions, okay? So we're going to hop right on in since we have a couple pages to do, and we're going to start with page 523. So Carmen has 4/10 of a dollar. Troy has 51/100 of a dollar. Together, what fraction of a dollar do they have? So Carmen is equal to 4/10. Troy is equal to 50/100, okay? So together, what fractions they have? This word together means we are adding. So we are going to add 4/10 plus 50/100, okay? However, we have 2 different denominators here, so that means we're going to have to change one into the other denominator. We're going to have to find a least common denominator, meaning a denominator that matches. Now, we have 50/100 here, and we know from the previous lesson that we can turn this 4/10 into a fraction that's equivalent in 2/100. So that's what we're going to do. So we have 4/10. If we make it equivalent to something with 100, all we have to do is multiply, right? So we know 10 times 10 gets me 100. Whatever I do to the bottom, I do to the top. So 4 times 10 is 40. So that means 4/10 is equal to 40/100. So we can substitute that in here. So now we can say 40/100 plus 50/100 is equal to, and now we keep our denominator since we did the work, we made them the same. And then 40 plus 50, we have 4 plus 5, which is 9, and we have a 10 here, so we're going to add a 0, okay? Or you can just know that 50 plus 40 is 90. So that means together, they have 90/100 of a dollar, okay? So remember, you need same denominators to add, right? You need the denominators to be the same. If you don't, it's like adding apples and oranges, right? It gets a little tricky when you start adding and they're not the same. So we know that if a fraction has a denominator of 10 and we have a fraction with a denominator of 100, we can easily change the fraction with a denominator of 10 into a fraction with the denominator of 100 just by finding an equivalent fraction, because we can multiply something by 10 to get to 100, okay? So keep that in mind. You need the denominators to be the same. You cannot add like this because then you can't keep the denominator, right? The goal is we want to keep the denominator the same. So we have to make sure they're the same before we can add, okay? And if you have any questions on that, please ask now. If not, we're just going to look at the model to go along with this, okay? So if you feel okay, let's keep moving on. So page 524, we could use a picture, right? So if this is Carmen's money, we know she has 4/10 of a dollar, and that's equal to the 4 dimes, because 4 times 10 is 40. 4 dimes would give us 40 cents, right? And then same thing with Troy. He's equal to 5 dimes because 50/100, 50 cents, so that's 5 dimes. And then if you just count them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. They have 9 dimes equal to 90 cents. Or 90/100, right? So we're getting the same answer, just with a different strategy. Sorry, my light's turned off. Also, the picture model with the base 10 is usually easier when the textbook or the iReady assignment does it for you, because obviously it's more accurate. But you also could have done it like this. You could have had, well, Carmen said 4/10. Troy had 50/100, and then just shading in the equivalent. But again, unless they give you the base 10 block with the boxes already drawn in, that can get tricky with proving equivalency, okay? So just remember, we need the same denominator to add. That is the main goal of this, okay? So you could have used the dimes and gotten the same exact answer. So if you don't have any questions, if you do, it's totally fine. Just pause here and ask. But if you do not, we're going to actually jump to page 529, okay? So, page 529. I actually fibbed a little bit. I thought we were going to be doing some subtraction. I think I was getting a little ahead of myself, so I do apologize. And we're just going to do 3 practice problems together, okay? So, number 1 on page 529 says, what is the sum of 7 100ths and 1/10? Show your work. So, sum, we're adding, but look, we have 2 different denominators. So, we have 7 100ths plus 1/10. Now, we have to make these denominators the same, and we know we can manipulate this one to make it equivalent. So, we're going to, just off to the side over here, we're going to say 1/10 is equal to something over 100. We know for a fact now it's 10 times 10 gets us 100. So 1 times 10 gets me 10. So that means 1/10 is equivalent to 10 100ths. So now we can plug that in and we can say 7 100ths plus 10 100ths. And now it's simple, right? We just add our numerators. 10 plus 7 is 17. Our denominator stays the same. And then we know that our answer is 17 100ths. Okay? So remember, we need these to be the same. If they are not the same, we cannot add them, because guess what? Then we would add the 7 and the 1, which is 8, and then we would add the 110, which is 110, and that is completely wrong. So we have to do it this way. We have to make an equivalent fraction and then substitute that equivalent fraction from what we worked with before, okay? So this one has a little bit of an extra step because you have to make sure your fractions are both in hundredths before you can add, okay? So we're going to go over 2 more problems. We're going to go over 2 and 3, and then you will work on your iReady today, okay? So number 2, Jared, Consuela, and Reggie have an ant farm. Jared collected 25 100ths of the ants. Consuela collected 6/10ths of the ants. What fraction of the ants did Jared and Consuela collect all together? Don't know why they brought up Reggie if he's not even in this, but whatever. So Jared, we're going to say J is equal to 25 over 100, and Consuela is equal to 6/10ths, or 6 over 10. Now, we have 2 separate denominators here, but we know that we can change this 6/10ths into an equivalent fraction with the denominator of 100, so that's what we're going to do. So 10 times 10 gets me 100, 6 times 10 gets me 60. So now when I add, I'm going to use this number for Consuela instead of the 6/10ths, okay? So now if we add them together, we have 25 over 100 plus 60 over 100, right? So our denominator stays the same. We add our 2 numerators. 60 plus 25 is 85. So what fraction of ants did Jared and Consuela collect all together? They collected 85 out of 100, or 85 100ths of the ants. Okay? And again, if you have any questions on any of this, please pause, okay, and ask. I will not know you have a question unless you ask me. Now we have number 3. Keith has 100 trading cards. Space exploration cards make up 7 100ths. Baseball cards make up 7/10ths. Together, the space exploration and baseball cards make up what fraction? So baseball is equal to 7/10ths, and space exploration is equal to 7 100ths. Again, we need common denominators, so we need to make this one with the denominator of 10 into a denominator of 100. So we're going to multiply 10 times 10 to get us 100, meaning we're going to multiply 7 times 10 to get us 70. So now we can add 70 100ths for the baseball cards plus 7 100ths for the space exploration cards, and that'll get us 77 over 100, meaning our answer is D. If you saw, I almost just picked C. I was trying to do it too quickly, so make sure you're paying attention to the numerator and denominator, okay? So, Ezra chose C as the correct answer. How did he get that answer? So if we look, we got 77 over 100, but it also looks like it could be interpreted as 100 plus 100, and that would give us the 200 as the denominator. So it looks like that's what Ezra did. So that's what we're going to say. So Ezra found that 7/10 is equivalent to 71/100, right? That was step 1. Then he added the numerators and denominators. Of 7/100 and 70/100. Instead of just adding the numerators, if the denominators are the same, we never add them, right? So instead of just the numerators, we do not need to add the denominators. They always match up. They always stay the same. So Ezra made that mistake today. Okay? So if you have any questions, please ask. If not, you are good to move on to your blue iReady lesson. That is due before our quiz on Wednesday, okay? So we have 2 full days to get this iReady done before our quiz. So tomorrow will be our review, quiz on Wednesday, okay? So I'm here if you need me. I'm here if you have any questions on any of this, or if you want to just go through some practice together. If not, you're in good shape to move on to your iReady. Good luck.